Through this demo document, I will present and answer the question related to AR and VR to summarize the development of these two technologies and my understanding of them. I will introduce what is VR and what is AR, as well as related the concept and practical applications and their difference. So there's a questions. First one, what's what's virtual reality, and what's its primary purpose, and how does it differ from other immersive technologies? Okay, first, virtual reality is a computer-generated simulation that enable user to interact with explore artificial 3D environments. It immerses users in the digital world, often using dedicated hardware such as head-mounted display, HMDS, and sensors or controllers. The main purpose of VR is to create a fully immersive experience that allows users to interact with the simulated environment as if they were physical there. And the difference from other immersive technology, compared with augmented reality AR, the VR creates a completely virtual world that separates user from their physical environment, but AR adds digital elements to the real world, bring together physical and virtual environments. Users are not fully immersive. So compared to mixed reality MR mixes physical and digital objects so they can interact in real time, providing a hybrid experience instead of incorporating elements of the real world. We are completely built as a separate digital environment. So, second, the two significant milestones in the history of VR development. And the first milestone is Thin-Roma. Is Synth-Roma. It's developed by Morton Howling. Synth-Roma is one of the first devices to attempt to create a multi-sensory immersive experience. It combines visual, auditory, and tactile feedback to users. It marks the birth of the concept of immersive multimedia experience. It demonstrates VR's potential to go beyond the visual immersion, influencing modern VR systems, and including audio and haptic feedback. So the second milestone is Oculus. The second milestone was Oculus Rift. It was developed by Palmer Luckey, and was the first customer VR headset to gain public attention. Its emerging has boosted the popularity of VR technologies and transforming it into a mainstream customer application. It triggered a wave of investment and innovation in the VR industry, and also in enterprise teach games such as Sony, HTC, and Google to develop their own hardware. Okay, and this how is VR applied in healthcare field? Yeah, we can say the VR provides a realistic simulation for medical students and surgeons to perform surgery in a risk-free environment. And the benefit, we know the medical professionals gain hand-on experience without putting real patients at risk. Facilitates learning complex programming in a repeatable and interactive way. VR makes the treatment more effective and reduce perceived pain during medical procedures. It reduces costs associated with training medicine professionals and conducting one-set workshop. Its immersive nature allows both medical professionals and patients to experience the benefits of innovation firsthand. Okay, Yeah, there are three types. There are three types of VR display. The second one is the second one is the head-mounted display (HMD). This were there are there are wearable devices that are replaced. No. This these are wearable devices that are placed on the users as to provide an immersive VR experience. They usually include things like motion sensors and sometimes built in handphone. These things, these things display images for each eyes, creating 3D effect. And sensors can also dedicate hand movements and update the virtual environment in real time. The second one, Cave System. Cave System is a cave automatic virtual environment. They are room-side installations with wall floors and ceiling acting as projection screens. Users will the VR environment through 3D glasses as they stand or move through the space. It allows users to move freely and interact with our environment. The last one is desktop virtual reality. Desktop VR system use standard computer monitors to display virtual environments, sometimes paired with input device such as keyboard, mouse, or game controller. The virtual environment is displayed on a flat screen, providing a limited sense of immersion. Users navigate the environment through input device, but there's no real-world tracking. And what is the haptic feedback in VR and why it's important? We know haptic feedback is virtual reality refers to the user of touch and force in a virtual environment to simulate the touch and interaction. It's achieved through devices such as gloves, controllers, or suits, equipped with signals that physical response. And why why is the haptic feedback important? Because it makes a virtual environment feel more real by replacing the sense of touch, provide intuitive feedback for actions such as grabbing, pushing, pressing virtual objects for nature and seamless interaction. So the the haptic feedback is essential to bridge the gap between the virtual and physical world, providing a richer user experience. Yeah. What are some crucial challenges in developing AR application? The first is technologically limited. VR handset requires a high resolution display and low latency and advanced tracking system, which can be expensive. And VR requires a powerful GPUs and CPUs to deliver smooth and lifelike graphics without latency, which may not be accessible to all developer and the user. And battery life is also a limitation because the VR device often because the short battery will reduce the usability for VR device. And the second is the user's feeling. Due to the mismatch between visual input and the inner ear perception of balance, VR experience can lead to simulator sickness. The low frame rates latency can cause discomfort. No. The low frame rates and latency will make users uncomfortable. and yeah, and it's also because of standardization, because the VR industry the common standards for hardware compatibility development frameworks and users interface. Developers face challenges when creating cross-platform applications that carry seamlessly across multiple devices. So also, this is the augmented reality AR, and it's different from VR. The first augmented reality is a technology that overlays digital content such as images, sounds, or 3D models onto a real world in real time. It enhances users' physical environment by integrating virtual mode by integrating virtual elements through devices like smartphone, tablets, or AR glasses. Unlike virtual unlike VR, AR doesn't create a fully immersive digital environment, but rather enhance reality with additional information. And the table shows the difference from AR and VR. AR, VR. Okay, and this one, the two examples of AR application in different industry, in healthcare, in surgery, and in education. The first one, Acumen. Acumen is an AR-based tool that projects a virtual map of the wound onto patient's skin in real time. It improves surgery accuracy and reduces error by helping medical personnel locate wound more accuracy. It saves time and speed up procedures, especially in challenging cases or in in children and elder patients. Yeah, and the second application is Google Inspiration AR. This AR allows students to interact with 3D models of scientific, historical, and geographical objects in classroom, and enriching the learning experience. Yeah. This one is the challenges and the limitations of mobile AR application. We know mobile devices often lack the precision, power, and the advanced signal needed for high quality AR. AR applications may express latency, low frame rate, or limited graphical quality, and reducing user satisfaction. For example, complex AR simulator, for example, complex AR simulators can drain the mobile CPUs and GPUs due to the constant use of cinema and precision unit. The AR application consumes a lot of battery power, so the short battery life is limited. The long use of AR application and yeah, and it also environmental constraints. For example, mobile mobile AR requires a well-lit and clutter-free environment for accuracy tracking and object detection. The last question. The two popular AR headsets and their own unique feature. First is Microsoft Holo 2. Its unique advanced hand and eye tracking. Holo 2 provide accuracy hand tracking, allows users to interact with virtual objects using natural gestures such as pinching and dragging. Eye tracking technology enhances users' interaction by detecting where users is looking and the users focus control. So The second one is Magic Leap 2. Uh, Magic Leap 2 can adjust the transparency of the lens to improve the visual effect or AR of AR in bright or dim light conditions. This feature enhances visibility and reduce distractions from real-world backgrounds, making AR content more vivid and clear.